and gentlemen, we have the presentation coming up by Shri Devendra Dutta Mishra, Executive Director, Rolling Stock, Maharashtra Metro Rail Corporation. Shri Devendra Dutta Mishra is an ex-Indian Railway Service of Electrical Engineers, IES 1990, and presently serving as Executive Director, Rolling Stock, Maharashtra Metro Rail Corporation Limited, Pune, Maharashtra, India. Mr. Mishra did his graduation in electrical engineering from Madan Mohan Malviya University of Technology in 1989 Gorakhpur, post-graduation in electrical machine and drives from IIT BHU 1991, and PG diploma in management from IGNOU 2007, and post-graduation in management public policy from IIM Bangalore and Syracuse University, USA from 2009 to 2011. And Mr. Mishra joined Indian Railway Services in 1991 and has served Indian Railways in various key railway electrification projects, workshops, and services in railway divisions. Mr. Mishra has an extensive experience over 30 years and expertise in system-wide project planning, development and management for metro rail, high-speed rails, railway electrification projects. Mr. Mishra has a long association serving in metro rail projects and high-speed rail projects as systems expert, DMRC Phase 1 and 2 and BMRCL Phase 1 and 2, Ahmedabad Metro, General Consultants, Japan International Consultants to Mumbai Ahmedabad High-Speed Rail Project, and presently he is serving as Executive Director Rolling Stock Pune Metro Rail Project Maharashtra Rail Corporation Limited, Pune. And over to you, sir, for your presentation.
Good day, everyone. I am D.D. Mishra, Executive Director, Rolling Stock, Mahametro, Pune. The topic of talk is new technology for refurbishment and maintenance of coaches. Technology upgradation of railroads, it is not just a choice, but it is a necessity and imperative for the railroads. Reason is there has been digitalization, trend of digitalization globally, and without digitalization, railroads also can't sustain like any other system. And moreover, railroad operation technology, and it has to integrate it. Railroads can't now work in silo. They have to integrate with other modes. So that is one of the other reason. And technology helps railroads achieve safety milestone also. Safety as well as environment. What are the milestones? What are the new world's requirement that to cope up with, railroads have to upgrade. Apart from that, the correlated factors are advanced algorithm and data analysis software, which allow the digital processing for different domains, operation and maintenance of the railroads. And eventually, purpose is to have the optimized operational cost. And certainly these are linked with maintaining a competitive edge, maximizing integrated approach of passenger services, and eventually to improve the life cycle of the assets. So by refurbishment and use of new technology in maintenance of modern railway stocks, precisely we can say we want to make the coaches more dynamic, means their higher hauling power capacity. We want to make them efficient, means they are better energy efficiency. As we discussed last slide, environmental friendly and digital, because we have to harness the massive amount of data being collected globally to enhance safety, reliability, and service to the customers, and an increase in the vehicle reliability. New functional features like automation and AI-based operation, control, maintenance, management, even to the level, we can say unmanned train operation, that is now the latest trend. And as we know, when changes arise, new challenges emerge, we have to face it, we have to manage it. So First thing is regarding system integration. One thing is inside our railway services itself, various systems, as well as integration with the other transport modes and infrastructures. So that challenge is always there, and it is linked with the software developments. We need very customized and high-end softwares, and that causes higher investment to satisfy the customer needs and ensure real-time data analysis. And when we make the system complex, there are potential error rates, and that demands functional safety approaches. And then sustainability, like what materials we are using, new fuel technology, climate change, all these things have to be integrated, because these are dynamic things. This is the changing world, so many global policies, regulation related to environment, material uses, those are coming, so that also has to be factored in. Then real-time monitoring, that is very important, because through that only we are able to achieve the artificial intelligence or automated operations. So use of embedded sensors, wayside a lot of equipments which can sense the different features which help in automated operations, then increased efficiency, safety and security. And ultimately maintenance part, we have to shift to predictive maintenance. Our approach conventional has been to preventive maintenance, which requires a lot of infrastructure, and we can never optimize. We have to basically, based on a certain preventive maintenance, which is sometimes over maintenance and very costly. So we have to go with the predictive maintenance. If we see the major manufacturers of rolling stock globally, some 7-8 major players, and accordingly the focus area, if we see how manufacturers plan the rolling stock, so there are 5 basic areas where mobility is the key factor, then safety, which is associated with least human error, and passenger protection. These are the basically main thing, and affordability is very important. Ultimately, this capex and opex. Ecology is a dynamic process, so energy efficiency, and of course humanity aspects where it has to be customer oriented, as well as localization of the jobs manufacturing companies have to take care. And when we talk about the high technology, means eventually if we, from the metro point of view, we talk, so unmanned train operations, this is the basically criteria. We can say this is the fully automated metro lines if we see from that perspective. So if we see the major metro systems like Paris, Budapest, Barcelona, Rome, Istanbul in these European nations, and then in China is now leading, Beijing, Seoul, Hong Kong, and Singapore is also leading country where automated a large capacity automation of the metro line has been done. In India, of course, Delhi of late automation, like Delhi has started DMRC a few lines with the fully automated. So we have, it is a beginning for India. Now if we come to refurbishment of metro coaches point of view, so these are the main, we can segment our refurbishment in these categories like vehicle interior, mechanical structure, electrical system, pneumatic system, train control and management system, HVAC, and communication system. So if we see from this perspective, so it is basically passenger focus, where passengers needs are to be catered by this upgradation, and simultaneously automated operation and safety aspects of the vehicle to be upgraded. So these both are the main key aspects taken in care when upgrading or refurbishment of the metro coaches being done. If we see pictorial presentation, just it is correlated with the previous slide where it has different systems which are part of the refurbishment has been shown. Some of late case studies of the upgrading of rolling stock, particularly in metro project context. So just a couple of cases can be quoted here. One is SMRT, Singapore Metro. So in 2016-18, they took up this refurbishment. The old more than 20 years old systems, they wanted to replace by refurbishment. Somehow it was not very, later on, they did at least some refurbishment work, but when they progressed, they found it is not very cost effective as well as what was the planned basically goal that achieved. Somehow it was not able to meet that expectation. So that way, somehow it was terminated in mid and then new procurements were done. So this experience somehow was not very encouraging. If we talk about India, DMRC RS1 first procurement of rolling stock, that was in 2002-3. There are a lot of issues, technical issues have been faced, and that is basically demanding refurbishment, like floor degradation due to aging, HVAC old technology now getting replaced, interior FRP painting that need to be attended, relay panel refurbishment, CCTV, because initial lot was not, it was without CCTV provisioning. Now it is part of the safety critical part, and then old TM's replacement with HETM and DRM display route, dynamic route display provisioning. Earlier it was basically one diagram, fixed diagram, static diagram, which is getting replaced with the digital route display. So these are the key areas. I am not very much updated exact what is the physical progress, but I understand things are rolling down. DMRC is taking up. Now, if we talk about the new technologies used in the maintenance of coaches, particularly in context of Indian Railway. So, two new technologies normally, although it is not very reliable, it is now very established technology globally. One is online monitoring system, OMRS, and second is coach maintenance management system. These are two being now used significantly. Most of the major depots now they are adopting. As far as OMRS, basically fault detection while train on run, an array of wayside sensors detectors which record noise and forces of the underframe equipments of the moving coaches, and then categorization of these sensed informations, alarms basically in yellow category, red category, accordingly to share alarms through the SMS or to the control room. And of course, it helps when you have advanced information. It is leading to faster maintenance and reduced turnaround time. So availability of coaches is improved. And then now, like Rajdhani, Shatabdi, important trains, they are old stocks are coaching stocks are getting adopted with the latest PICU, passenger information coach computing units, which record wheel slip provisions, CCTV, toilet order, panic, all the passenger related services are also, those informations are coming and they are integrated with fire alarm and detection system, air quality, choke filter sensor, energy meter, all this. Similarly, this coach maintenance management system, which is oriented to the depot information, digital transaction of information from the depot. So various maintenance activities, both mechanical as well as electrical, captured at the point of origin, either origin depot or where defects are attended. So then those information can be digitally accessed by the control. Being web-based, direct access of data by train controllers, maintenance engineer at their own end. Say one train is originating from Delhi, if defect is attended in midway, say at Secunderabad. So these informations from the origin at the origin depot, origin control, all this seamless information can be, it is possible to share and participate. And certainly this avoids voluminous paperwork. Even break certificates are being issued now from the maintenance line directly to the platforms, which were earlier taking a lot of formality due to so many formalities, a lot of time. So now it is possible. So platform, it saves the time. Unnecessary delay in operational handling at platforms, that is now getting avoided. And then system is now proving helpful in monitoring the performance of coaches, ensuring satisfactory services of passenger, various passenger comfort related like light, fans, air conditioning, toilet fittings, water system, which are the usual complaint areas from the passenger point of view. So precisely we can conclude that technology is now helping in aiming to shift from the earlier practice, conventional practice of predictive maintenance to the preventive maintenance. So just if we try to actually capture the key elements when we want to implement refurbishment or maintenance of rolling stock successfully. So these are the few points I think they are important to be considered in planning, designing and implementing our system. So first thing is acknowledgement of intended improvement of refurbishment, proper understanding if we are doing interiors, passenger facilities outside, how much it is compatible with the life cycle, like under frame life, all these things, old coaches, say 18 years coach. If we are doing some kind of decorative work to refurbishment or passenger facilities, how much it is compatible with the life of the balanced life of the train, that is very important. So intent should be very clear. Then inspection of rolling stock, there are statutory requirements also, refurbishment, then it needs inspection and then evaluation, proper audit evaluation of changes. And certainly when load distribution, all these items of the under frame, those are the critical areas. So fresh finite element analysis, all these points need to be taken care. And then integration of the new subsystems, how they are integrated in the existing old stock, as well as how to replace the existing systems by the new system. So these are the challenges. It should be well planned. And then control softwares should be well planned to ensure functional safety and new hardware's units. Maintenance procedures should be well thought in advance. It should not happen that a certain gap or some surprises occur at the maintenance stage. And then all the technical documentations, old documents, O&M manuals, all these need to be upgraded to match with the refurbished situation. Challenges also come regarding obsolescence management. So some of the equipments, some of the parts may become obsolete. How we are going to manage? These are the challenges. And then this final design has to be verified by some third party, proven some expert agencies, production stage inspections. And important is our railroads have very strict regime of standards which they have to follow. So it is very important that refurbishment or any upgradation, it is complying with the EN standards or whatever the applicable standards. And then what are the reactive changes of other systems? And total system, as already we mentioned, this weight distribution, clearances, SOD compliance, safety against derailment, braking system, electrical power supply, fire safety, all these aspects, implication, their fallouts has to be considered. Some new thoughts, because when we take the things large scale, it's a financial viability as well as a smooth process management. Those are the key areas. So if we say some way forwards, how we can enhance in the volume of basically application of new technology in our old stocks. So we can say it needs a more analysis and futuristic approach. And for the coach is basically OEM oriented and the car builders. So it is very important that OEMs, integrators are equal partner in this upgradation as well as maintenance. Like Japan has very good models where the OEMs as well as the suppliers and the rail company, operating company, they basically make some good company which they are the key stakeholders. So they make some independent organizations, sister organization, which are taking care for the upgradation and maintenance. So such kind of, by participation of all the stakeholders, some entities can be created. That is possibility there. And O&M organization, always they need financial supports, in-house expertise for design development. That will be in long run, it will prove economical. So that is also equally important. And all the asset management, life cycle, use of 5D, BIM, all these aspects are there where every asset is tagged, history is available for the better management. And standardization of inventory, that also helps in addressing challenges of capex and opex. If inventories are standardized, so we can minimize the inventory. And for the precision quality works, particularly welding works and so many other aspects related to the coach manufacturing, use of robots and the computerized operation, CNC machines, those are the key part to achieve better qualities. And most important part is the skill improvement of the basically our skill power engineers, associated designers. So their institutional development, advanced training, compatible with the new systems, new technology. So of course, participation of OEMs, technology providers, that becomes very important. So with this, we can say technology will enable in the development of reliable and sustainable railway systems. So this was presentation from my part. Now I welcome the questions. I would like to clarify and answer a few points. Thanks.